All right, folks, we are moving on in our unit. Well, actually, we're just starting a unit. How about that? A unit on parallel and perpendicular lines. And in the geometry textbook, it's chapter 3, but we're not going to do all of it. So I'm going to focus on parallel and perpendicular lines. I'm going to call it part 1 because chapter 3 has an interesting design, and I'm going to do something a little bit different. So I'm going to chop it up a bit, and then we'll go from there. So anyway, all the part in the unit here that we're going to cover is being able to visualize parallel, perpendicular, and skew lines, segments, and planes as well. We're going to be naming angles when two lines are cut by a transversal. What is that? We're going to talk about properties of parallel lines, including one cut by a transversal. What's the deal with that? And then parallel and perpendicular line theorems, as well as their converse. And we're going to apply some algebra on top of that, and then we're going to wrap up the entire unit with constructions of parallel and perpendicular lines. Yay, compass. So we're going to begin this with the first chapter, or the first lesson in the chapter 3.1, lines and angles. And what we're going to cover basically is talking about parallel lines, skew lines, and naming angles when cut by a transversal. So we're going to focus on some of that. Now, there's all this yummy stuff that exists in the book. You know, you talk about these key concepts with pretty pictures and the vocabulary, and, you know, talking about parallel lines and parallel planes and what's the deal with skew, and I'll talk about that in a little bit. And then we get into another neat chart, neat key concept about angles formed by transversals, and you have this whole page here. And we're just going to jump into some activities that will help you with the vocabulary for this, basically. So to jump in, we're going to talk about, well, a picture, really, and begin our journey through this lesson with this neat picture here. Okay, so we're going to have a picture of a rectangular prism. Now, I'm going to give that to you, that this is a rectangular prism. So some of my students that were keyed into me talking about questioning everything, good for you. But this, I'm giving this to you, this is a rectangular prism. Okay, so now we're going to answer some questions about what's going on. So the first question, it really brings up the word parallel, right? So we're going to talk about, well, what does parallel mean? Well, you know, they're never going to intersect. They have the same slope, right? All this other stuff about parallel segments. And so the first thing we need to do is visualize, well, where's segment AD? And as you remember, okay, so here's our segment AD. What are all these segments parallel to it? So if this is our given segment AD, we have all this other parallel stuff. You know, this is parallel to it, same slope, never going to intersect. But you know what? BC is also parallel to it, will never intersect. And you know what else? FG is also parallel to it. So we have a few things. We have 3 line segments that are actually parallel to it. And so we're visualizing that, right? That was the thing from the unit. We got to visualize that the segments that are parallel to AD are also segments EH. So we can write that. And we're going to make sure we're careful with the way we write things. We have segment BC, okay, so that as well is a segment that is parallel to AD. And then lastly, way in the back, that back corner there, segment FG. Okay, so we know that those are the segments parallel. So now we have a good, well, hopefully a better understanding of what parallel means, right? So now we get to this thing called skew. What a neat word, skew. Okay, so we got to figure out what parallel means. Well, hopefully you know, like, or have a good vision of what parallel means. I'm going to demonstrate with 2 pens here. Okay, so parallel here, right? Parallel here, no matter how I move the pens, okay, they're parallel. So no matter what's going on, okay, these pens are parallel. So what in the world is skew? Okay, well, skew is basically not on the same plane and not parallel. Okay, so if I skew a pen, let's say take the black pen, stays where it's at, right? And I'm going to skew the red pen. All I got to do is tilt it a little. And now it is skew from the black pen on a separate plane and not parallel. Okay, so on a totally separate plane, not parallel, that's skew. Okay, so parallel, right? And we'll get into perpendicular later, right? Totally perpendicular. And then to skew that, whoop, just take that perpendicular segment off of the plane. Now you have two skew lines, right? So now we have to figure out what, making sure we understand what skew means, right? So here we're going to talk about the second question. Explain why segment FE and CD are not skew, okay? So first we look at segment FE. Here's segment FE. Then here's CD, right? Why are they not skew? Well, because they share a plane is why they're not skew, okay? So why they're not skew? Because they're on the same plane. Okay, there's that invisible plane that's cutting that rectangular prism diagonally. Okay, so they're on the same plane is why they're not skew. Okay, so they're on the same plane is really the explanation. But let's talk about skew. Okay, what would be skew to segment FE? Okay, so let's make up our own question now, which is a neat thing. What would be skew to segment FE? And so we look at FE, here's segment FE, and we're visualizing what's going on here. Skew, okay, not parallel and not on the same plane, okay? So off the plane and not parallel. So skew to FE could be AD, for example, right? Segment AD is skew, not parallel and not on the same plane. That's skew to FE, right? Here's FE. AD is totally not on the same plane. How about DH, okay? That's skew. Okay, so skew to FE would actually be like AD, DH, CG as well. Okay. Oops, that's a C. Okay, so those are skew. And that's what skew means. Now you might be thinking, well, what about if this is FE? What about AE? Right? Is AE skew? No, because AE and FE are on the same plane. They're on the same plane, right? So they're totally not skew. Okay. So hopefully you have a better understanding of what skew means. So make sure you know that word. It's such a fun word to say, skew. Anyway, I'll stop boring you. On to the next thing. What is another pair of parallel planes? Well, I don't know what the given pair of parallel planes was, so let's just start naming parallel planes. Right, so now we're going to look at faces of the rectangular prism. Okay, so we take a look at our rectangular prism, and let's talk about the front face real quick. Okay, so let's look at the front face, and hopefully you can't hear the lawn work going on outside. The front face, that front face is plane EAD, I'll call it. So there's our front face, is plane EAD, and then parallel. Here's the yard work. Parallel to that plane, parallel to that front face is the back face. Okay, so parallel to the front face is the back face. And the back face is plane FBC, right? We can call it that. That's the back face. Okay, so when we're looking at the diagram, okay, so we have our front face, plane EAD, and the back face, plane FBC. Those are parallel. Okay, and I'll do one more example. How about the left face? Okay, so let's look at the left face of the rectangular prism. The left face is over there. Hopefully you know your left from your right. And so the left face would be plane EAB. Okay, so the left face would be plane EAB, and that would be parallel. Oh, check out that shorthand. The left face, plane EAB, would be parallel to the right face, and the right face is over on this side, right? So that would be plane HDC, or however else you would like to name it. Okay, plane HDC. So we have our parallel planes. Okay, that's how that works. And just one more: the top face and the bottom face, of course, are parallel. So if we look at the top face, plane ADC. Okay, so we're visualizing geometry. The top face is parallel to the bottom face, plane EHG. Okay, so those are parallel as well. Is that cool? So hopefully you understand a little bit better parallel planes, right? So now we have a good understanding of that, or you should, right? Anywho, now this next question. It's such an interesting thing. Segments parallel to a plane. That is so fun. Segments parallel to a plane. Well, how's that possible? It's just a segment, but it's parallel to a plane. That means they're not on the plane, okay? Not on the plane, but are parallel to it, okay? So first let's find this plane that we're referencing here, DCGH. And DCGH is the right face, okay? So we're going to find two segments that are parallel to DCGH. That means they're not on the plane and they're not intersecting the plane either, okay? So not on the plane or not intersecting it either. So I'll add that as a note, okay? So not on the plane and not intersecting it. Okay, so what's going to happen? So we look at that right face. A segment that's not on the plane, it's parallel to it, but not going to intersect it. Well, it could be the two segments out here, segments AE and BF, right? Those are parallel to it because we're visualizing geometry. Okay, so we could talk about segment AE or segment BF. Those are not on the plane, not on the right-hand face, right? And also not intersecting it. But there are a couple others. Okay, hopefully you see two other segments. What about these two, right? What about AB and EF? Those are also not on the right face and also not going to intersect it. So those are parallel segments as well. So legit responses would be AB and segment EF. Okay, so those are also correct. They are segments parallel to the plane, not on the plane and not intersecting it. Okay, they would be parallel to it. So hopefully this is helping with some vocabulary. It's a great way to build your notes. Remember, use words in your notes, okay? So hopefully we have a better understanding of parallel and skew. Okay, parallel and skew. And so now what we're going to do is jump into naming angles, cut by transversal. What? So angle pairs formed by a transversal. Well, what the heck is a transversal? Cuts two lines. That's what a transversal is. Cuts two lines. Transversal. Cuts two lines or more, right? Cuts two or more lines. So that neat chart in the textbook on page 142 has everything here. We're just going to dive in and name some stuff, right? So this is what's happening. We have basically lines M and N being cut by the transversal R. Okay, so first we have to see what's happening. So we have line M and line N crossed by transversal R. Okay, so cut by, I like using the word cut because like, cut by transversal R. That's the picture we're looking at. Okay, so with line M and line N, cut by transversal R. This is the picture we're looking at. And what happens in a case like this, we have two lines cut by transversal, you have a bunch of angles that get formed, here in this case 8, right? So you have angle 1, angle 2, angle 3, angle 4, angle 5, angle 6, angle 7, angle 8. Now these angles have relationships to one another, and those relationships have names, and we have to know those names. Okay, so the first, there's no particular order. The first vocabulary for names that we're going to talk about are corresponding angles. Now, you can define this whichever way you choose. Personally, I like to say that they're in similar positions, right? So my own definition, this is just cat's talk here, I just call it that they are in similar positions. Now, what does that mean, right? What does that mean that they're in similar positions? So if I have my line M and my line N, and it's cut by the transversal R, I have two angles that are in similar positions. Here's an example. Take a look at angle 1, right? You see angle 1? So focus right now on angle 1. In a similar position to angle 1, right, where it's basically the the upper left side of the corner here. Well, what's the other angle, right, in a similar position in the upper left? Over here would be angle 3. Okay, so angle 1 and angle 3 are totally corresponding. All right, so that's what corresponding angles mean. They're in similar positions. So what if I was looking at angle 8, right? If I look at angle 8 in this group of angles is like the bottom left. So in a similar position over here in the bottom left would be angle 6. Those are corresponding angles. Okay, so angle 8 and angle 6 are corresponding. What if I look at, let's say, So let's go backwards here, and I look at angle 4. Okay, so let's look at angle 4 now. I should probably have been showing the picture the entire time. We look at angle 4. Angle 4 is up here in this group of angles. Angle 4 is up in the top right, you know. So over here, what's in the top right? Angle 2. Okay, so angle 2 is corresponding. And then what's another pair? Let's look at, we haven't looked at 5 and 7 yet. So what if I said, you know, let's look at angle 5. What would be corresponding to angle 5? In the group of angles here, angle 5 is like in the bottom right. So in this group of angles in the bottom right would be angle 7. Those are corresponding angles. Okay, so take a look at the picture, right? And take a look at the angle pairs, 1 and 3 corresponding. Okay, 8 and 6, 2 and 4, 7 and 5. Those are corresponding angles. You have to know that vocabulary. Holy cow. I'm so frustrated right now with my students. If you're listening, yeah, I'm talking about you, because you guys are not really focusing on your vocabulary. I'll say words for things and you'll just go, huh? So make sure you know the vocabulary. Those are corresponding angles. Super important, okay? Use the vocabulary when you talk, right? If you say to people corresponding angles, you sound really smart. Anyway, on to the next vocabulary. Alternate interior angles. What in the world does that mean? And here, again, Kat's definition. I say it's on the other side of the inside, right? What? I call it on the other side of the inside. That's my own definition, right? That's just how I visualize it. But those are called alternate interior angles. So what's happening again in the photo? More yard work coming. So we have our two lines, transversal, and we're looking on the inside. Okay, so the inside is here, right? So what's on the inside? In the interior is 2 and 7 and 3 and 6. Those are interior, those are inside, right? So that's on the inside. Alternate interior, I say on the other side of the inside. So for example, on the inside, the only interior angles are 2, 7, 3, and 6. So if I look first at angle 2, for example, angle 2, the alternate interior angle on the other side of the inside, right? The only choices I have are 2, 7, 3, and 6, but what's on the other side from 2 to 6? Those are alternate interior angles. So I call that angle 2 and angle 6. And of course, the other pair then, the interior angles being 2 and 7, interior on the inside, the other angle pair would be angle 7 and angle 3. Okay, so those are alternate interior angles, what I say on the other side of the inside. On to vertical angles. And this, my friends, like I told you, I'm frustrated with my students right now. What I consider the most basic concept of angles, we still do not use academic vocabulary well, and so I'm frustrated with my students. So make sure that you are saying vertical angles when you're talking about vertical angles. Now, I throw vertical angles in here because, again, they're super duper important. Vertical angles are across the x, right? Across the x. So we look at our diagram here, and we can see all the vertical angles. Hopefully, you know, like angle 1 and angle 7. We better be good at this by now. Angle 8 and angle 2, right, across the x. You know, angle 3 and angle 5, and then angle 6 and angle 4. So those are the vertical angles. This is a review piece from chapter 1, right? So we know that stuff. Okay, and now we have this other vocabulary. Alternate to exterior angles now. Okay, so alternate on the other side, right? Exterior on the other side of the outside now, right? This is how it's Kat's vocabulary. This is how I remember it. Okay, on the other side of the outside. That's how I remember alternate exterior angles. So exterior means outside, right? Exterior is outside. And so we look at our diagram. We only have 4 angles that are in the exterior. Okay, so we have 1, 8, and 4 and 5. Those are on the outside. Those are the exterior. So what are the alternate exterior on the other side of the outside? So let's say I look first at angle 1, let's just say. Can I even look at angle 2, 7, 3, and 6? No, I can't, because those are not on the exterior. I can only look at the exterior angles. So if I look at angle 1, what would be on the other side of the outside of angle 1? And I only have angle 1, angle 8, angle 4, and angle 5. It would be angle 5, right? That's on the other side of the outside, right? So that's my alternate exterior angle. And the other angle pair, alternate exterior, hopefully you've figured it out by now. Angle 4, angle 8. And that is alternate exterior, okay? Okay. Now, same side interior sounds exactly how it sounds, right? It's what it is. So if we're going to talk about Kat's vocabulary, I'm going to say it's on the same side of the inside, right? Same side of the inside now. Because interior is inside. Look at all this vocabulary you're learning, right? So it's kind of cool. Same side interior angle. Interior, inside. So we look at our diagram again, we only have 4 interior angles, right? These are the interior angles. Interior is inside. Interior is inside. So same side of the inside, right? Same side interior. So if I look at, if we have angle 2 and angle 3, and angle 7, angle 6, those are same side interior. Okay, same side of the inside. So angle 2, angle 3, angle 7, and angle 6. Those are your angle pairs for same side interior. And that is the vocabulary. Now the best way to learn this stuff is to say the words. Please, I'm so frustrated. So the best way to learn this is to say these words. Okay, if you use these words in my class, and I'll totally annoy you. Mr. Katz, help, and I'll say, what are we looking at? You better say alternate exterior angles, or alternate interior angles, or same side interior angles. You have to use that vocabulary. Anywho, let's move on. Let's show the practice. Okay, so here's like a nice little, a lesson check, right? Let's do some practice here. This is in the book as well, and we can answer. I'm just going to answer these really, really quickly. So this is in the book as well, and I'll just go through and give you a couple of examples of an answers. And so, do we know how? Always read the directions. Name one pair each of the segments, planes, or angles. And so for this diagram here, we're going to use it for exercises 1, 2, and 3. So this 1, 2, and 3 is only for this picture here, and then 4 through 7 is this picture here. Okay. So 1, 2, and 3. First question number 1. Give me parallel segments, right? One pair of parallel segments. It doesn't matter which one. Let's say I'm looking at GC first, right? So any segment parallel to segment GC, pick one, doesn't matter. I could use F, B, E, A. I'll pick HD, why not? Okay, so I'll say segment HD. Of course, there's many other answers, but that's good enough for that. Okay, number 2, skew segments. Hopefully you remember what skew looks like. So I'm going to start with any given segment. How about segment EF? Okay, so if I start with segment EF, let's pick something that EF is skew to. So EF is over here. Skew would be not on the same plane and not intersecting it. So it can't be HG because that is actually on the same plane. There's the plane. And it can't be DC, that's on the same plane as well. But skew to EF would be like HD or GC. How about HD, because that's already becoming a popular response, right? HD, HD. So that's that. All right, number 3, how about parallel planes? Doesn't matter. Pick any 2 faces of the rectangular prism. And we do have to assume that this is a rectangular prism. So I'll start with any plane. Let's pick the top face. Why not? Top face. FEH. So plane FEH. And that would be parallel to, parallel to plane, the bottom face, right? How about BAD? Bad. Okay, so that's parallel planes, right? Yay, we're learning. Moving on. Number 4 through 7. Okay, so any pair of alternate to interior, alternate on the other side of the inside. Okay, so where is the interior? The interior is in here. Okay, that's interior. So alternate to interior would be the other side of the inside. So if I look at angle 8, it would be alternate interior to angle 6. The other side of the inside. Okay, the next question, same side interior. Here's my interior. Let's look at angle 8 again. Okay, so here's angle 8, same side interior, angle 3. And then corresponding angles, I mean, they're in the same position, right? So let's say if I look at, angle 7, for example. Angle 7 in this group of angles is on like the right-hand side, so corresponding to that would be angle 6. and then alternate exterior on the other side of the outside. And so I look at my exterior angles. Here are my exterior angles. What's on the other side of the outside? How about angle 1, angle 4? And that's how I work on that. Okay? So I'm going to wrap it up. Call it a day. Yeah, we have this the open-ended stuff. Feel free to write some words in there, especially number 10, right? Carly and Juan examine the figure to the right. Carly says AB, here's AB, is parallel to HG. Here's HG. Juan says, no way, dude. AB is skew with HG. Who is correct? And explain. Hopefully you know what is skew. Carly wins. I'm done, and enjoy. Make sure you do all your practice. Peace.